Hello, welcome back to physics. We're going to wrap up our discussion of instantaneous velocity, also talking about average velocity because they kind of go together like peanut butter and jelly. What we have is the graph here on the board. It's a position time graph. So this describes the motion of something like a bicycle, somebody on a bicycle or something as time goes on. And we want to find 5 things. Don't let them scare you. They're all very easy. What is the average velocity of the entire trip? In other words, from start all the way to point C. What is the average velocity between 0 and 4 seconds? So that would be between these 2 points, in other words, up to point A. What is the average velocity between 4 and 8 seconds, meaning from between A and B right here? What is the instantaneous velocity, not average, instantaneous velocity at 2 seconds, exactly at this point right there? What is the instantaneous velocity at 5 seconds, which is somewhere right between here, exactly at that point? So let's take them all in turn, and if you've been following the discussion up until this point, you probably can anticipate some of the answers even without doing any calculations, which is what I really want to see. So if you can get that far just without even doing anything, especially for the last 2 problems, good for you. If not, then we'll go through the calculations and you'll see it by the end. Average velocity of the trip. Well, we want to find the average velocity. There's only one equation that deals with average velocity, and that is the following. The average velocity, this is part A, is delta x divided by delta t, right? What is delta x? Delta x is, again, we're going between 0 and, the entire trip from here to here. So what is delta x? It means you start at 0 and you go, how far did you go? C ends up at 10 meters away from the front door, right? So the final position, meaning remember xf, minus the initial position is 10 minus 0. That's just final minus initial. And then on the bottom we have time. Again, starting from here, how far away is C in time? Well, it's only 12 seconds away. So delta t, you could write it as 12 minus 0. So what you have is 10 over 12. And if you put that in your calculator, what you're going to get is 0.83 meters per second. That's the average velocity between the starting point and point C. Now notice that it's 0.83 meters per second. But that doesn't tell you anything about what's actually happening in the middle here. In other words, as long as I start at point A and I end up at point C at 12 seconds later being 10 meters apart, then, I'm sorry, 10 meters apart 12 seconds later, yeah. Then I'm going to calculate the same average velocity no matter if I do this, or what if I start down here and then go way far at the end and reach C? Or maybe I start out this way and wiggle around a bunch on this curve and I end up at C. It doesn't matter how I go between the starting point and C. Because average velocity only looks at the subtraction of the endpoints of distance and time, I can go any number of ways and I'm still going to get the same average velocity. That's why it's called an average.